on Blackboard. So if you solve this, you can go to the next one. If you go to the lectures folder, scroll all the way down, you'll see term exam 1 review, and the questions are posted there. Okay, so first question. It's a projectile question. The golf ball is struck with a velocity of 80 feet per second, as shown. Determine the distance d where it will land. Okay, so this is very much like a simple projectile problem, except that the ground is not level, but it is tilted. Okay, so one way to do it is if you can set up an equation for, well, if you can find the time it takes to go from A to B, then you can find the distance d. So let's try to set up equation for x and y position of B, and see if we can then use that to solve for the range d. Okay, so I'm going to set up an equation, two equations. One is for the x position of d, it's x0 plus VA cosine 45 degrees times t, where t is the time taken to go from A to B, and then yd is y0 minus VA sine 45 degrees t plus half gt squared. Did I get the signs right? I think I got the signs wrong. So upwards is positive, so this has to be positive, and downwards is negative. So okay, so we cannot apply that equation unless we choose a coordinate frame. So we'll choose a coordinate frame this fashion. So this point is the origin. So x0 is 0, y0 is 0. Should be B, not D. Okay, so xb is 80 cosine 45 degrees t, yb is 80 sine 45 degrees t minus g is 32.2, so 16.1 when you divide it by 2 times t square. Okay, so I have two equations now. The issue is that what I'm after is I want to find this distance d, and this point is xb, yb, and clearly d what's d in terms of x, b and yb? Yeah, you could write it that way, or so this is one way of writing that, or xb equals d cosine 10, right? And yb equals d sine 10. Okay, so is there enough information to solve for d? Can you try to solve for d and poll the answer? So if you zoom this is actually, my bad. So this angle is not 45, but it's 55. The angle made with the horizontal. Good catch. This is incorrect. So this should be 55. So anybody solved using 55? Okay. Okay, I'm going to stop the poll. But this, I'm not going to count it towards your grade. Don't worry about the poll. Okay? So don't freak out about it. So I see multiple people got this answer. I just solved it on the board. Okay, so I'm going to stop it. Don't worry about not polling the answer. I'm not going to count this. So 166 is the answer. Yeah, I have to grade it, but don't worry, I'll erase this particular phone after it's done. It won't show up on your reef. Okay, so consider the mass pulley setup shown below. The inextensible string is pulled with an acceleration of AB to the right as shown from rest. Find the acceleration of A in terms of B. Okay, so let me solve the first part, and I would like you to solve the second part. Okay, so this is a problem involving absolute motion. Okay, we need to set up the. I've given an algorithm of how to solve this. We first set up a coordinate frame. So let me choose a coordinate frame which is to the right. So this is my datum line. Just because it's convenient to look at x motion along the x-axis with positive going to the right. Now I'll draw lengths, define variables from the datum to points of interest. So one point of interest is B. So I'll write xb for this, and then the other point of interest is A, but that's the same as the motion of the center of the pulley, which is right below this one. So that's xa. Okay, now can you set up an equation for the length of the cable? I think actually you can actually try to do this problem. I thought it was slightly involved, but it looks like it's simple. So I would like you to solve. I've set up the problem. You need to find the length of the cable, differentiate, and find the acceleration. What I would ask you to do is just poll the answer for AA divided by AB. Okay, it's that way you're polling a number. So find AA divided by AB and poll your answer. Okay, I'll start solving in about 30 seconds. Okay, so let's set up a equation for the length. So I changed my datum to over here. If you want to put the datum at the original place, you'll have to only define length of this, and that length here, the one which I've shown, the L. Let me call that L1. That L1 will be a part of the equation. When you take the derivative, it'll actually cancel off. So really, a good choice for the datum is this. Not that the other one was bad. So let's set up an equation for the length of the cable. We have this, the first part, the topmost part here. That's xb. Then there is this part and this part, which are the same length. This is the distance between the two walls, and that does not fit time. So plus d plus d, and then this part and this part, which I've shown in blue, is xa plus xa. So really I should have put this datum is here, so it should be, this should be the xb and this should be xa. Okay, so length is xb plus twice d plus twice xa. So differentiate it once. L dot equals 0 equals xb dot plus a derivative of d, which is constant, is going to be 0. So 2xa dot. And so if you differentiate again, you get 0 equals xb double dot plus 2xa double dot. And so this is AB equals So AB plus twice AA equals 0. So the ratio of AA divided by AB is going to be negative 0.5, half, yeah. Okay, is that clear? QD goes away because it's constant. So this is how the class did. There were 7 people who got it right. Another person who got 0.5, that's right.
Yes.
Okay. Okay, so let's solve the next part. Okay, find the time it takes for A to move a distance of 2 meters from rest. Assume AB equals 2 meters per second squared. So find the time it takes for A to move a distance of 2 meters. So SA is 2 meters. And I think we are also given the system starts from rest. So the velocity of A initial is 0. And you're given acceleration of B, that's given to be 2 meters per second square. So we can find acceleration of A. Now that we have an expression for acceleration of A in terms of B, acceleration of A is minus 0.5 times AB, which is minus 0.5 times 2, which is minus 1. The minus indicates that when B moves to the right, A is moving to the left. Okay, so how do I find the time to move a distance of 2 meters? How is S related to T? What formula do I use? A equals dV over dt. Okay, you can use that, but then you'll have to, well, you could use that, but you have to integrate that twice to get S. So that's absolutely one way to do it, but is there a direct way where you don't have to integrate? V dV ds. So V dV ds is A. The thing here is that you're given the time and you're not told the final velocity. So this formula will not work. Well, it will work, but you'll have to be 2 steps. So the easier way to do it is actually in your formula sheet. Your formula sheet gives a formula which you can just plug in. There are just 3 formulas. When things are moving under uniform acceleration, there are 3 formulas which are valid. If you go to the formula sheet, just get it. Okay, you can use one of these formulas provided A is a constant. If A was not a constant, so the way I could twist this question is if I gave you AB is not 2 but it was 2T or 2S, then you will not be able to use this formula and you'd have to use the VDVDS, one of these formulas. Anyway, in this case A is constant, so you could use one of these formulas. Which one would you use? The top one or the bottom one or the middle one? The middle one, right? Because S is given, initial velocity is given. The top one gives you velocity as a function of time. This one gives you position, so I'll use this one. Let me write that down. So S equals S0 plus V0t plus half AT square. So S is 2 meters equals S0 is 0 plus V0 is 0 plus half acceleration of A. In this case, I'm going to use the absolute value just because let me use the value which as it is given, t square. Okay, if I use minus 1, I actually have to change my S. My S has to be negative. And the reason is because the block moves towards the left, right? When it moves to the left, that's against my convention is positives to the right. So when it moves to the left, it has to be negative. So I need to put the value with the right sign. So so if you solve this, you get t square equals 4, and so t equals 2 seconds. Seven seconds. So 7 is right here. Can you find and poll the answer? Velocity at t equals 7. What we're trying to do is we're trying to find what this value over here is. So what I like to do is, and this probably is, so we're going to find the slope, but the way in which I like to do it, and this is probably easiest to write the formula down, is to write the coordinates of 2 points on the line. So in this case, the coordinate of this point is x is 6, y is 10. Coordinates of this point are x is 9, y is, well, 0 because it's on the x-axis, and this point, the coordinates are x equals 7 and y equals v. So now if we have 3 points, then we have to find the slope. So what I'll do is I'll take the y coordinate of any 2 points. So let me take the y coordinate of 7 comma v. So v minus 10. So y coordinate, subtracted them out, and then 7 minus 6 equals, I'll take this point and this point next. So 0 minus 10 divided by 9 minus 6. So minus 10 divided by 3 is the thing on the right. So v equals 10 plus 7 minus 6 is 1 times 10 divided by 3, and that comes to be 2/3 of 10, which is 6.67 meters per second. Okay, so this point here is 6.67. Yeah. So, I mean, there are some answers like 23. I mean, 23 is nowhere on the plot, so you cannot have a 23 value. 20. When I graded this exam like 3 semesters back, the people who got answers which were beyond 0 and 10, you can't have an answer beyond 0 and 10 because, I mean, just think of it. The velocity only goes from 0 to 10. The answer has to be between 10 and 0, right? Anyway, let's move on to the next part. B. So find the distance traveled from t equals 0 to t equals 7 seconds. Okay, so let's try to understand how velocity is related to the time. Sorry, to the distance. So ds dt equals v, right? And so ds equals v dt. So if you were to find the distance covered from 0 all the way to 7, s equals 0 to all the way to the final time, which is 7, then I need to integrate v dt from 0 all the way to 7, right? Because time goes from 0 to 7. Now, one way to do it as well, you could take the slope, write equations for the different pieces and then do integration, but an easier way is to look at the area under the v dt plot and try to find the area. So I'm looking at the area. So this area, then this one, and then the final one is all the way from 6 to 7. So 0, 2, 6, and 7. So I need to find the area which is shaded there. So S is equal to first the area in the blue line, so that's going to be half base times height. So half times the base, which is 2, times the height, which is 10. Next is going to be the green part shown. That's going to be area of a rectangle. So the base of the rectangle is 6 minus 2 for the time axis, 6 minus 2. And then the y-axis is 10. And for the third part, I have a trapezoid. You could break down a trapezoid, the red part, into a triangle and a rectangle and find the area, but if you knew the trapezoid formula, it's much easier. The formula for the area of a trapezoid is half times the base, which is 7 minus 6, times the sum of the heights. So this height is 10, and the other one is 6.67. So if you sum this up, you get 58 point, it comes out to be 10 plus 40 plus 8.33, which is 58.33. Okay, and part C, draw the acceleration time plot. Okay, why don't I leave it to you? I will post the answer with the AT plot, but I will leave that to you. So do it yourself and then check with the answers. I'll go to the, I have 4 minutes, I'll go to the fourth question. So try yourself, I'll post this. Okay, any questions on A and B? Angular speed of theta dot equals 2. Determine the magnitude of the velocity and acceleration of the peg P. Okay, find the velocity of P and acceleration of P at theta equals 30 degrees. The peg is constrained to move in the slots of the fixed bar CD and rotating bar AB. So what's happening here is the bar AB is rotating. It's going counterclockwise. So it's going this way. But the peg is going to move only in the in the vertical direction. It's not going to move sideways. So find the velocity of P and acceleration of P. So this is actually a problem in absolute motion. If you can find a coordinate, well, we have, my bad, we're given r equals 4 sec theta. So it's not a absolute motion problem, but it is a problem in r theta coordinates, right? Because you're given r equals 4 secant theta. Okay, so how will you set up an equation for velocity of P? Yeah, so V equals VR ER plus V theta E theta. So VR is R dot ER plus V theta is R theta dot E theta. So as long as we can find R dot and theta dot, we're good. So let's try to set up. So I'm trying to solve for R dot and R and theta dot. So theta dot is known. Theta dot is 2. So we know theta dot. Okay, we do not know R and we do not know R dot. So how can we solve for? Okay, so 4 secant theta. So we know that. That's good. So we know that. So we can take the R, plug it in here, and then R dot is simply the derivative of 4 secant theta. So do you remember the derivative of secant theta? Secant and tangent. Yeah. Secant theta, tangent theta, and then I need to do theta dot, otherwise that's not a derivative with respect to time. Okay, so this is going in there. So solving for this gives me yeah, question.
What's that after, like the R dot? Is that an E? Is that an L? Is that a U? Is that a... No, stop. Those are red.
Where it says V equals?
V equals R dot something. Something. The ER. Yeah.
ER. The U.
Yeah.
Above it, the U.
My bad. So another way of writing the unit vector is actually ER. Let's sort of skip that. So it's UR and U theta, unit vectors. So V equals VR square plus V theta square equals 10.7 feet per second. Okay. Now what you should do is, and I'll post the answer, try to find acceleration. Okay. And the answer is 24.6, but I'll post the solution in a bit. Okay, so I'll see you on Friday for the exam, first exam.